Algebra 1 Semester Review Part 3, Problems 11, 16, and 18. Which of the following tables identifies the ordered pairs that belong to the parent function for a linear equation? The parent function for a linear equation is y equals x or f of x equals x. Remember, when you see notation f of x, that simply says if the input is x, the output is f of x. Remember that really dreadful chicken nuggets film? Input, output. On to problem 16. Which of the following is best modeled by a linear function? An inventory decreases, gets smaller by 400 items every week for 6 months. 1, 2, 10, 20, 24. Seems to me if it decreases by 400 items a week every week, this is likely to be linear, but we always read all the answers. A bank account growing at 1% per month for 36 months. This is compound interest. It is not linear because the 1% is paid on the previous month's balance. So it does not change at a constant rate, cannot be this. A population of elk decreasing by 1/10 every year. Again, as it decreases, the percentage is from the prior year, so again, that's a decay function. And a child growing 1/20th of her height every month for a year, good for her, but the height is based on the prior month's height, whereas with the inventory, it goes down a very reliable 400 items a week, every week. The only place you might get tricked here is 0, 1, 2. You might want to put in 3, 4, 5, 6, 7, 8. That was 16. Now we will look at 18. The algebraic form of a linear function is d equals 11.5h, or we could say f of h is 11.5h, where d is the number of dollars earned, h is the number of hours worked. Which of the following describes this function? For every 11.5 hours worked, $1 is earned. Only in sweatshops overseas is this true. $1 for every 11.5 hours is not the same thing as $11.50 an hour. A person earns $11.50 for every hour worked. This seems to be the same. Do we stop? No, we check all the answers. If we work 0 hours, do we get paid $11.50? Ooh, no, I would like to have that job. Don't show up, don't do anything, and we still get $11.50. Oh, but at the end of 2 hours we only have $23. Well, at the end of 4 hours we have $46. This is $11.50 an hour, but we're getting paid for an hour we did not work, so this is not linear. This goes up by 2, but this is not going up in exactly the same way. This is not the answer. 1 hour, $11.50. 3 hours, $34.50. Is that true? Let's see. I know what we can do. We could put this in our calculator. First we turn it on. We clear everything. 1 hour, $11.50. 3 hours, 3 times $11.50, $34.50. 5 hours times $11.50, that should be $57.50. This isn't correct either. This can't be the answer. We are left with B. And finally, let's look at problem 20. The company charted the depreciation. Depreciation is loss of value over time. When you buy a new car, it depreciates. When you buy a used car, it depreciates. He includes the table in his report to the company. The values create a line graph. What is a correct interpretation? Well, we can graph the data. Time is the independent variable, or the x-axis. The depreciated value is whatever it is. We assume this is a linear function. So we could graph this. How would we graph it? One year, 2 years, 3 years, 4 years, 5 years, 6 years, 7 years, 5,000, 10,000, 15,000, 20,000, 25,000. After 2 years, $21,000. After 4 years, $10,400. After 5 years, $5,250. The x-intercept is 6, so the computer system depreciates $6,000 in 1 year. Well, there's no cause and effect here, and after 5 years there's less than $6,000 in value. That answer doesn't make much sense. The y-intercept is $31,500. Could be. The y-intercept is $31,500, so the system depreciates $31,500 in 1 year. Well, no, because it has more value than that at the end of 2 years. The slope is negative 10,500, so it depreciates $10,500 in 1 year. No, because the change from here to here is 2 years. I think the depreciation may be $5,250 a year. What else do I want to do with this? I can put the data into the calculator, and I think I'm going to do that just to see what happens. Clear out the old list of data. 2, 4, 5. Now I move over 21,000, 10,500, 5,000 to 500, back to Stat, over to Calc. Number 4 is linear regression. My slope is negative 5,250. My y-intercept is 31,500. So my correct answer is B, and I can verify that either by graphing or by calculating more of the data points.